Additive synthesis is a constructive technique. It allows us to build sound from the ground up by modeling and shaping its harmonic content. Instead of filtering away, that was the case in subtractive synthesis, we take now the opposite direction. A variety of digital tools for additive synthesis are available in software such as Reactor, Logic, and of course, Ableton Live. In additive synthesis, we combine waveforms at different frequencies, amplitude, and phases to build a complex waveform. Additive synthesis is about creating a timbre or the color of a sound. Just as the frequency of a sound wave relates to the pitch of a sound, in the wave theory of light, the frequency of a light wave relates to the color we see in the light spectrum. As a higher frequency sound has a higher pitch and a lower frequency sound has a lower pitch, a high frequency in the light spectrum will show violet, a low frequency red. This correspondence between hue in color and pitch in sound is also present in the way we describe the timbre or tone color of a sound with words such as bright, dark, or warm. In synthesis, we begin with the premise that all complex sounds are the sum of single frequencies. That is why, when we look at the spectrum of a complex sound, we see multiple frequencies. Hence, all complex sounds can be decomposed into single frequencies. Sound can be broken down to single sine waves. Like ripples on the water, different waves can collide and be together to form complex waveforms. How do we reverse a complex sound and break it down into its simpler components? That is exactly what a spectrum analyzer like this one does. It measures the magnitude of an input signal versus frequency, and it does so thanks to the French mathematician Joseph Fourier. In the early 1800s, he discovered that anything that vibrates generates a fundamental perfect wave, called a sinusoidal wave, and that all overtones are multiple of that fundamental and thus easily to unveil. That's why our point of departure is always a pure mathematical sine wave, consisting of only a single frequency. Fourier analysis has many scientific applications for measuring the wavelengths of light, statistics, forensics, cryptography, acoustics, oceanography, even to analyze the wave patterns of the mountain range in geology. In Ableton Live, we can do additive synthesis with operator instrument. We can build a complex sound using any of these 4 oscillator sections. We go to the first oscillator and then we click the oscillator tab. By default, it shows a sine wave at full volume, but we can grow more harmonics using the 16, 32 or 64 harmonic editor. With the button repeat, higher harmonics can be generated by repeating the drawn partials beyond the 16, 32 and 64 harmonic. Use the phase button to change the start point of the waveform. We can use what we already learned last tutorial on subtractive synthesis and use filters to subtract harmonic content and the LFO to modulate the filter. With the glide function, notes will slide gradually from pitch to pitch. We also have a pitch envelope and the spread parameter that creates a rich stereo chorus by using two voices per note and panning one to the left and one to the right. If we want to synthesize a monophonic instrument like a flute, we can choose one voice in the global settings. Draw voice textures, kind of wave shapes, by creating clusters of harmonics. We can also use the 4 oscillators together. In the global settings, click at the last algorithm to continue with additive synthesis. We select a sine wave in the first oscillator. To modify the frequency of the second oscillator, coarse sets the ratio in whole numbers, creating harmonic relation. Fine sets the ratio in fractions of whole numbers, creating inharmonic relationship. Fixed mode do not respond to note pitch, but instead play a fixed frequency. This frequency is constant regardless of note pitch. We can create a bell kind of sound that has these characteristic widely spaced harmonics. We can use 2 oscillators for this. Then we modify the envelope of each, modifying the sustain and the release time. Maybe one more oscillator to add some inharmonics. If 4 oscillators are not enough, we can also use an instrument rack and have multiple operator instruments working at the same time. So now we have 8 oscillators, 4 in each instrument. We can keep adding and adding partials to build our timbre. This was the fundamentals of additive synthesis. Next time we're going to take a look at FM synthesis.